working. So we're going to go over parallelograms again, just reinforce those rules that we talked about yesterday, apply them to quadrilaterals, and then we'll get graph paper later because I'm going to show you how to graph them and decide just by looking at a graph if it is a parallelogram. So the very first thing in your notebooks is what we talked about yesterday. But it's like the converse. It's backwards of what we talked about yesterday. So if you see a four-sided shape and you notice the opposite sides are congruent, both pairs of opposite sides are congruent, because then it has to be a parallelogram. What does it have to be? What does it have to be? Parallelogram, but check. Both pairs of opposite sides have to be congruent. So that's the first theorem. Now, remember from yesterday, guys, do I care if you remember that it's theorem 6.6? No, I find that a ridiculous requirement. Don't worry about remembering the numbers, just more the content. Okay, next one, we're going to same thing as yesterday, only backwards. If you're looking at a four-sided shape, a quadrilateral, and you notice the opposite angles are congruent, then it's going to have to be a parallelogram. It's going to have to be a parallelogram. But remember, opposite angles, they're literally across from each other. They're opposite of each other. Check, check. Okay, same as yesterday, only backwards. If you're looking at a four-sided shape, a quadrilateral, and you notice that consecutive angles are supplementary, then it has to be a yes, it has to be a parallelogram every single time. So remember, consecutive is one right after the other. So angle A plus angle B has to equal 180. Angle B plus angle C has to equal 180. Angle C plus angle D has to equal 180. One right after the other. This was new yesterday. Same as before. I feel like I'm saying the same thing over and over. If you look at a quadrilateral, a four-sided shape, and you notice that the diagonals bisect each other, then it's a parallelogram, right? Okay, now be careful. Let me put a picture up here. Check, 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 check. First question, is that a quadrilateral? Okay, so what if you notice that the picture has diagonals in there, but what if on the picture it looked like this? Check, 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 check. Is that a parallelogram? No, they're not bisecting each other. This piece is not the same as this piece, so be careful with that. Okay, next one. Oh, this is a new one. Absolutely new. Okay, if you notice in a quadrilateral that one pair of opposite sides are both congruent and parallel, it's going to be a parallelogram. But you got to check, it has to pass both those tests. So one pair is both congruent and parallel. What happens is that it forces the other pair of opposite sides to be parallel. Remember, the most basic definition of parallelogram is that opposite sides are parallel. Both pairs of opposite sides. Okay, here we go. Right here. Looking at this shape. First check, is it a quadrilateral? Has the four sides. Okay, now, how do we know that it's a parallelogram? So same thing as yesterday, we're just going to write a reason for it. Ali, what are you thinking? Perfect. Do you agree with Ali? Opposite sides are congruent? Yay, nay? So if opposite sides are congruent, is it going to force it to be a parallelogram? Yep. Done. Think that's good enough? I say that's good enough. Call that good. Same thing with yesterday. Stick with your reason. Oh, this part. Okay, we're done with the notebooks. So if you want, you can close them. We're going to switch to graph paper and do the rest on the graph paper. Okay. These ones can be rough to think about. It's all the rules that we just went over, which were a backup of yesterday's stuff that we went over. We just got to decide, is this enough information? So number one, if you've got a shape, check. They tell you it's a quadrilateral. So let's just think of this. If we know the opposite sides are parallel, is that going to guarantee that it's a parallelogram? So I'm just going to add in my symbols. This is parallel to this, that's opposite sides. This is parallel to this. Opposite sides, give me a thumbs up. Yes, parallelogram, thumbs down. No, not a parallelogram. Let me see your thumbs. Yes, that's the most basic definition, right? That would have to be a parallelogram. So this, yes, is enough information. Okay, what about this, though? Do you think the picture is good enough for explaining? I'm okay with that. If you want to put down the reasons like we did yesterday, but my only issue is, don't you think, like, this is the reason already? Draw it every bit. Yes, opposite sides are parallel. Okay, number two, opposite sides are congruent. So let's do the same thing. So draw yourself a quadrilateral. This is congruent to this. This is congruent to this. Okay, was this one of our reasons? If opposite sides are congruent, does it force it to be a parallelogram? Yep. So this, yes, that is also enough info. Okay, number 3. Draw yourself a small picture that just meets these requirements, but it has to have 4 sides. So draw yourself a picture first. Try it on your own. Okay, thumbs up. Yes, parallelogram, that's enough info. Thumbs down, no, not enough info. Let me see your thumbs. What did you get on this one? After you showed off your pictures. Okay, I'm seeing a lot of thumbs down and a few thumbs up. So, what do you take from that? A lot of thumbs down. You probably can draw a picture that's not a parallelogram. If you can draw a picture that's not a parallelogram, then that's not enough info, right? So, are you ready? This is actually a shape we're going to talk about, I think, later on this week. So 2 pairs of consecutive sides. Consecutive is just one right after the other. So like this side is congruent to this side. Check, check. You okay with that? All right, but it still has to have 4 sides because the direction said it's a quadrilateral. So what if I just stretch this way out? This is congruent to that. What do you think? Do those sides look parallel to each other? This one and this one? Probably not, right? What about this one and this one? Probably not. And then also you can check the diagonals. Watch. Let me choose a color that will show up. So this one, this diagonal to this diagonal. Okay, maybe right here. Do you think maybe this is the midpoint of that one? Maybe. But what about this way? No. Heck no. So what do you think? Parallelogram or not? Nope, not a parallelogram. Okay, question. Do you know what kind of shape this is? Raise your hand. Anybody? Anybody? Yes, it's a kite. It's a kite. Diamond kite. Okay. No, it's not a rhombus. Definitely not a rhombus. Guys, make the little like window like this. Okay, mine doesn't work. My thumbs are little. Rhombus always has to have 4 equal sides, but it can be tilted. But it still has to be 4 equal sides. So rhombuses are very similar to squares. Is this a rhombus? No, because not all sides are equal. Okay, last one, number 4. Same thing. Try to draw yourself a picture that meets those requirements, but it has to have 4 sides. Good luck. Awful thinking. So I was thinking this. I was thinking, all right, well, just because consecutive angles are congruent doesn't mean it's a parallelogram, because I was thinking, what if you had like a 33-degree angle? Let's just make it easy. 30-degree angle, maybe like that, right? But then this one also has to be 30 degrees, so maybe like right there, and then I got stuck. Because then I was thinking, well, it's a quadrilateral, so every single quadrilateral has to add up to equal. So then I was like, how can I make 2 more angles that fit the 360 requirement? And then I was like, I don't know. So does anybody have a picture where you're like, I think my picture works to prove it wrong? Abigail, how did you do it? Okay, then we were talking about that in the morning class. So technically, we could have, well, that's more of a rectangle, but it doesn't really matter. Because in the rectangle or the square, all the angles equal. What are they equal? 90. So technically, are consecutive angles congruent? So that would support the yes, right? So there's our yes version, but do you think we could come up with a no version? I don't know. Ellie, what are you thinking? Do you want to come try to draw? Okay, come on up. Yay! Okay, so check it. Would this side be parallel to that side? It could be, right? However, is this side parallel to that side? No, those would eventually cross. So they get going, Ellie, yay, good work, good work. Do you know what shape this one is? Travis, Ellie, good work. We'll get into that later. Okay, let's see what's next. Okay, this one. This one, we're stuck with this shape every single time. And then we're stuck with number 1 all by itself. Just knowing number 1, is that enough info to say this is a parallelogram? So like I tell you to do, draw over pictures. And I know you're working on your graph paper, so just stay with me. So on this one, We know E is the midpoint of AC. So right here, that would be congruent to that because that's the midpoint. And BD, this is congruent to that. Nod your heads or shake your heads. Yes, enough info, or no, not enough info. What do you think? Okay, now tell a neighbor. Yes or no? Okay, yes. Yes, yes, yes. It's talking about the diagonals, right? So if you need a reason, you can say diagonals bisect each other. Oh, too big. Okay, the next one, it was another debate. A good discussion in my last class. Okay, it starts all over. You don't know number 1 anymore, it's just number 2. Number 2, you know that ABC, where is it? ABC plus BCD equals 180. Okay, I want you to tell a neighbor, what do you think, yes or no? Okay. Alright, curious. Get ready to read your friends. How many of you said yes because consecutive angles are supplementary? Yeah, I agree with that reasoning, right? Consecutive angles are supplementary. But then the debate got brought up in last class. Don't you need to know that every pair is supplementary?
Yeah, but they're equal to each other anyway, so you know that like they would equal. No, because they're only equal to each other if you know that.
If it's parallelogram, right? So can we come up with a counterexample for this one? I'm just gonna sketch it right here. So if we know that this is, I don't know, 60, what would this one have to be? If they're supplementary, 120, right? So can we make a shape that has different angles? Like this is not 120, maybe this is like 100. If this is 100, this would have to be, because it's still a quadrilateral, right? Is that possible to make that shape?
No, because the 100 is not the same.
Can we make those sides match up? Later on in this chapter, we're going to do construction. We'll get more into that. For now, let's just say that this is safe enough. This is yes. And then we'll get into our constructions and decide if that's enough. Okay, start all over. Number 3. Number 3, we know the side is parallel to the side. Is that true? AB, DC, check. Check. BC congruent to DA. Oh. This one congruent to this one? Okay, tell your neighbor. Yes or no? What do you think? Okay, you ready? Okay, check out number 3. Check out that extra picture I added in. I know it's a different picture. Number 3, look at that picture. That extra picture, is that a parallelogram? That'd be our trapezoid, right? But does it meet these requirements? Does it have one pair of parallel and one pair of equal? It meets the requirements, so I'd say this is a dangerous one. Look at your picture and be careful. However, when you look at this picture, it looks like it's a parallelogram. Just be careful. Do you know the perfect description for this shape? We already went over it. It starts with a T. It's a. You gotta put one adjective in front of it. Do you know? What's the word that stands for 2 equal sides? You have 2 of them right here. Yeah, isosceles trapezoid. Isosceles trapezoids have one pair of congruent sides. Okay, let's go to number 4. Number 4, what's this one? ABC. Again, draw in your picture. Make sure you get them right. ABC congruent to ADC. Oh, perfect. And then BAD. Check, check. BCD. Grace, you got this. Whisper with your neighbor. Go, go, go. Be confident. Tell me what you get. How come? Wait, how come? Tell me the reason. Perfect. Opposite angles. Congruent. Okay, number 5, number 6. Remember these from our triangle chapter. Take these and break them up into pieces and write all over your pictures. So I go one thing at a time. And I deal with the sides first. Now number 5 is called a congruent statement because they're congruent to each other. So start here, you ready? Has to be written in order. AB has to match DC. Do you remember going over that? Order matters. So where's AB? AB congruent to DC. We're doing good. Okay, next one I'm going to do BE congruent to CE. BE congruent to red flag. I would stop there. Do you think that's a problem? Because shouldn't that have been right here if it was a parallelogram? I'd probably stop and say, no, not a parallelogram. You can keep going though. Question.
What if the diagonal bisects each other, but each side is still the same? Does that make sense? Like, without words?
Let me make sure I understand your question. So you said, what if you come up with something where the
Like
sides bisect like this? Check, 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 check.
But they're all the same size. Like, let's say there's two lines that are same exact length, and they bisect each other, but they're both the same, right?
But it has to be a square. Your situation, that only works in a square.
But that's parallel.
Squared parallelogram. Yep. Good one. Okay, last one. Oh, I see what you're saying. So maybe this one was congruent to that one. That one, we wouldn't have enough info to know for sure it's a square. I see what you're saying. Okay, thanks. Thanks for clarifying. Okay, last one. We've got AB, CD. Where is it? AB, CD. BE, DE. BE, DE. And the last one's AE. And C. Stop. I'd say right there, that finished one rule. Is that a parallelogram or not?
Yeah.
Yes. And we can just say diagonals bisect each other. Perfect. Guys, good work on that one. Okay, on that one, you guys got it. Okay, here we go. Heads up, on your assignment tonight, you're going to have 2 questions exactly like this one. In the directions, it says, prove that the points, these ones, form a parallelogram. Now, proving it is more than just sketching it like, looks like a parallelogram. You've got to either show that it's parallelogram by slope or distance formula. So let's do this first one together. I like slope. Do you mind if we do slope first? Grab your graph paper, sketch those 4 points really quick. I'll do the same. All right, A2, -1. Don't forget to mark it with A. B13. C6, 5. D71. Check. Whoa, did I mess something up? Oh, yes, I did. D71. There we go. Okay, hopefully eyeballing it. Okay, just by eyeballing it, does it look like a parallelogram? What do you think? The opposite sides look parallel? Okay, but now I've got to prove it. So let's show it by slope first, and then I'll show you distance formula. So the slope of AB, start at A and go to B. Now I teach my 7th graders, slope is like you're holding a balloon, and then you let go of the balloon. Where does the balloon go first when you let go? And then it catches the wind, right? It goes over. So go up first. Start at A, go up. 1, 2, 3, 4. So 4 up, and then backwards 1. So the slope of this one, leave it in fraction form, is 4 over -1. Up 4, back 1. Now we want to see if that has the same slope as CD. If they have the same slope, that means they're parallel. So let's find the slope of CD next. I'm going to start at D, go up 1, 2, 3, conveniently 4, back 1, same thing. Okay, you have just shown that AB is parallel to CD because they have the same slope. But now we got to do the other 2. So same thing. Same steps. Let's find the slope of AD. So start at A, go up 1, 2, over 1, 2, 3, 4, 5. All right. Leave it as a fraction, just up 2 over 5. BC, hopefully it's the same. Up 1, 2, over 1, 2, 3, 4, 5. Okay. So again, right here, opposite sides parallel. Right here, opposite sides parallel. You just proved it. showing slope. Nod your heads. You get that. Does that make sense? Again, I prefer slope. Not the distance formula is hard, it just takes some time. Okay, you ready? Last one. Distance formula. First, graph these points. Go for it. Go. Oh, it's like a skinny monster, huh? Yeah. Ooh. How many have a shape kind of like mine? Super squashed parallelogram, right? Okay, here we go. Distance formula. Distance formula, d equals the square root of x2 minus x1, don't forget to square it, plus y2 minus y1, don't forget to square it. Deep breath, here we go. We've got to find the distance of every single side. Stay with us, stay with us. Okay, so let's find AB first. For AB, I'm going to use this -2 as x1 and this -4 as y1. And then this one as x2 and this 2 as y2. Stay with us, make sure you're writing this down. Okay, so x2 is 1 minus the -2. Don't forget to square it, plus y2 is 2 minus the -4. Don't forget to square it. Alright, so that's going to be 1 minus -2, that's 1 plus 2, 3, 3 times 3, 9. Plus 2 plus 4, 6, 6 times 6, 36, equals square root of 45. Well, I'm going to stop there and not even worry about it. You can leave it around for form. And don't worry about simplifying those radicals. Okay, looking at the picture, AB should be the same as CD. So let's do the same thing for CD and make sure that they're the same measurement. So we've got CD. Up here, I'm going to use this, x1, y1, x2, y2. Okay, so x2, -1 minus 2, don't forget to square it, plus 4 minus 10, and then square it. 1 minus 2, -3, -3 times -3 is 9, plus 4 minus 10, -6, -6 times -6, perfect, 36. How many got the same thing that I did? Did you get the same? Okay, check. We've checked one pair of opposite sides. Those are congruent. They have the same distance. Same thing. Let's quickly do the opposite pair. So we've done AB and CD. Let's do, how about BC? Alright, BC, I'm going to use what I left up there. So BC, x2, what I have up there, I'm going to do 1 minus 2 squared. Plus 2 minus 10 squared. 1 minus 2, -1. -1 times -1 is 1. -8 times -8, 64. Done. Leave it just like that. Last one. Oh, AD, that worked out good too. I'm going to use what I have up there still. A is going to be x1, y1. D is going to be x2, y2. So we've got -1 minus a -2 squared plus 4 minus a -4 squared. Alright, -1 plus 2, +1. 1 times 1 is 1. Plus 4, that would be 8. 8 times 8. Hooray! Distance formula. So I feel like, again, you've got to be confident with using the formula. It just takes a little bit longer than the slope, right? Alright, let's get